Hi there. This video series is to display my problem solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I am showing my approach to solving the 30th Project Euler problem from start to finish, vocalizing my thought process throughout. As always, I will link to Project Euler and my repository in the description. Let's dive in. Problem 30. Digit fifth powers. Surprisingly, there are only 3 numbers that can be written as the sum of fourth powers of their digits. And then it lists them and displays it as 1 equals 1 to the 4th is not a sum, it is not included. The sum of these numbers is blah blah blah. Find the sum of all the numbers that can be written as the sum of fifth powers of their digits. Okay, so it is unclear, for me at least, how high these numbers could go, or what condition would make it clear that we've definitely hit the last one. So what I am going to do is I am going to create an assumption based on the fact that these sum of fourth powers of their digits numbers are all, perhaps coincidentally, 4 digits long. I am going to assume that all numbers that can be written as the sum of fifth powers of their digits are at most 5 digits long. Is this a fair assumption? We'll find out. There can't be very many of these numbers because the fourth powers numbers, there's only 3 of them. So let's operate under that assumption at first. So do our little doohickey where we create our file. Really starting to get a lot of these at this point. Do our silly thing that I love to do where I do the print. And then have our little limit variable, and in this case I am going to set the limit to 100,000. So, is that correct? Yeah, so that'll mean we won't even bother looking at any numbers that are more than 5 digits. And then we're going to have I'm just gonna call it numbers, and it's going to be a list. And then for in range, let's go ahead and start with 10. It doesn't really make sense to start there. But it shouldn't be a big deal. So 10 to limit. And what we want to do is if n is the sum of the fifth powers of its digits, then add 2 numbers, and then at the end we just want to do a print sum numbers. So obviously this if statement, realistically, that's where all the hard work is. So we're going to just create a if is sum of fifths in there. And then of course it's going to be like this doesn't exist. So def is sum of fifths in, so starting out by just returning false so that we are at a state of compiling. But how do we actually say that this is true? So there's a few different ways that we could do this, right? And I think the easiest is to do a string conversion. So we're going to have digits equals that. Then we're going to say sum equals 0 for d in digits, sum plus equals d to the fifth, and then we want to return sum equals n. So what this should do is and actually I'm gonna go ahead and move and create, let's see, I just want a simple variable here that's like power equals 5. So that I can change that to 4. So in order to test this, I would like to run it with the limit being only the 5 digits and the power being 4. And if that outputs this 19316, then our program works. Okay, it wants there to be more spaces. That's fine. So oh, of course. 19316, 19316. So our algorithm works for the power of 4 at least. It works really, really quickly. My guess it's going to work similarly quickly for the power of 5 because the way we're doing this, it's an O of n. Even as the n gets a little bit bigger, it's not going to dramatically increase. So we have this number, came up with it in less than 2 seconds. Let's see if it is the correct answer. It is not. So it seems likely in this case that there's a higher number that we missed because we proved that our algorithm works, but we don't actually know the largest number that can be written as the sum of fifth powers of its digits. So we're just kind of taking a stab in the dark as to how long that number is. Okay, so obviously we're still getting a larger number. Let's increase it one more. And again, it's only taken a couple seconds to run. So now it might take a little bit longer. Oh, less than, okay, so now it might take like 20 seconds to run this part, but we are still getting the same number. So the longest was this one, which ran in about 2 seconds. So I am relatively confident that this is the correct answer, but let's find out. And it is. So, okay. Now, there is one issue with this, which is, other than making this number arbitrarily large, there's not a good way for this algorithm to know that it is done. So, if I were faced with a similar problem, as the numbers that this power number gets larger, obviously I would have to arbitrarily increase this, meaning that the program would just take longer and longer and longer to run. It would be way better if we just kind of iterated number over number over number without any, like, this is definitely the last, or without a limit, but with a way of discovering, like, okay, we've found the last one. So that is a future enhancement that I would make to this program if we were trying to solve a larger problem. But we got the correct answer. Our algorithm works great for this. I'm gonna rename this, actually, is sum of powers. So that we have this power equals 5 still be clear. And yeah. Okay, so I'm just gonna do P here. Power equals 5 is sum of powers and power. Okay, so that's still gonna work. Let's see that we're taking only a couple of seconds. That works great. But for this, cool. We are complete. We found the correct answer. We did it in a way that I think is relatively clear. We basically use string conversion and then integer conversion. And then we use this built-in sum function to avoid having to do extra work on our own. But I think we're all set for this one, and I'll catch you in the next.